Have you ever noticed that during a solar eclipse, you see crescent-shaped sunlight projections on the ground when the sunlight passes through the spaces in the trees? In fact, this bizarre effect happens when partially eclipsed sunlight passes through any hole and projects the inverted image onto the ground. This is known as the pinhole camera effect. The shape of the light source, which could be in the shape of a crescent as the moon passes in front of the sun during a solar eclipse, the light would pass through a small hole and project an inverted image of the crescent onto the other paper. So why is the image of a crescent showing up upside down when it passes through a hole? Well, it's pretty simple. Light travels in a straight line. When light from the top of the light source passes through the pinhole, it reaches the bottom of the paper. When light passes from the bottom of the light source, it passes through the pinhole and reaches the top of the paper. In this experiment, I made a triangle-shaped opening on the flashlight lens. When the light is on, it projects a triangle shape onto the ceiling. Now let's do the same when the triangle-shaped light passes through the holes of a drain strainer. The same thing happens. Like an eclipse crescent light projection, the triangle-shaped light passes through the holes of the strainer, and its inverted projected triangle image can be seen on the ceiling. During a solar eclipse, the shape of the light source, which in this case would be the sun, changes. As the moon passes in front of the sun, the light source, or the sun in this case, shape changes to a crescent shape, and that light passes through small spaces in the trees, creating the crescent-shaped light projections you see on the ground. The smaller the hole, the sharper the image.